this is actually now working. I don't know. Perfect. This is playable. Yeah, we did an ollie. Today's video is going to be a head-to-head comparison test between the newly released Claude Opus 4.6 model being used through Claude Code versus the newly released GPT-5.3 Codex model being used through the Codex command line tool. Now, I wanted to go ahead and do something that was a little more involved than a simple software-based task, and for that I have decided to integrate a hardware feature to this just to make it, one, a little more difficult to actually properly get this right, and two, a little more entertaining to watch as opposed to something that is just purely software. So I brought a physical element into this, which we will now take a look at as I reach down to the table right here, and hopefully it is visible to see this. If not, I will just cut to some B-roll of it. So what I'm holding in my hand right here is a little mini skateboard project that I had started building almost 4 years ago to control a Unity game using an MPU 6050 accelerometer attached to an Arduino Uno R3, and then there is a little Bluetooth dongle here as well to actually send the telemetry to the computer running the game. And essentially what this would do is the board would actually physically transpose its orientation in space into a skateboard in a digital game, therefore making this kind of like a little controller for an actual skateboard game. Now, the difficulty with that is obviously it stays stationary, so really only the lean back and forth would work, as well as perhaps popping the tail and allowing that to initiate an ollie or something of the sort. So today's task is going to be partially Arduino related and partially game related and partially C++ related, etc. With an overview of our physical prompt, which is of course the skateboard, now let's take a look at the actual prompt these models will be given when deciding how to go about implementing this entire project. So we can see it right here. I probably won't necessarily read this verbosely, although that would probably be a good idea in a dedicated coding video. So I have a physical skateboard with an Arduino system attached to it, designed to capture board telemetry and send it via Bluetooth. I have given them the hardware setup. The Arduino setup is as follows. The MCU is the Arduino Uno R3, the sensor is the MPU 6050 accelerometer, and the communications are the HC05 Bluetooth module. Following that, I have just given them the current wiring configuration of the skateboard controller, and I did initially verify that everything was wired properly and the Bluetooth module was properly transmitting the telemetry data from the accelerometer, as I want to avoid any human error mishaps in this test. Following that, we see a simple project goal. The skateboard is intended to be used as a physical controller for a skateboard game running on the computer. Following that, we have the requirements for the models to actually produce for us. First, the Arduino firmware. They need to write an Arduino script to read telemetry from the accelerometer and send it via Bluetooth through the HC05 module. Our second deliverable is a C++ skateboard game, which if you had watched my previous testing of either of these models independently, thank you, and you also know that this was something I tested both of them with, and they both did a really potent job in it, so it'll be interesting to see it immersed with a physical component as well. And we can see right here, the prompt is build a C++ game to reflect the movement of the physical skateboard. The game must feature an animated person that rides a skateboard, which I know from testing either of these independently, they're both capable of actually building a little tiny rigged animated rider. The map must be a skate park, no strict design requirements, but it must look good and function well. Now for the controls, we have the lean of the physical skateboard from left to right. So basically, when standing on this, if it turns left or right like that, in terminology of the lean, must control the turning of the rider in the game. When the tail of the physical skateboard is stepped on, meaning the nose raises, it must initiate an ollie in the game. I don't know how well it will actually be able to do that, especially considering that the accelerometer is mostly mounted in the midpoint of the board. So there may have to be some threshold value that's taken between like a rapid rise and one of the telemetry figures to actually figure that out, unless I placed it somewhere else on the board. But this is kind of part of the test, is letting the models figure that out, I suppose. Pushing. Because the physical skateboard is stationary, the computer mouse will function as the forward control button. Map the game skateboard forward motion to just our left mouse button, just to make things simpler. For connectivity, the game must work with the Arduino script, and this is where they'll have to kind of have some cross compatibility, because this is going to be a C++ game running on our host system. However, it's going to have to input telemetry from the Bluetooth module running on this skateboard device and then translate that into skateboard movements. So these are going to need to communicate with each other in a functional way, which is essentially what the connectivity step right here says, telling it the host system is running Ubuntu 22.04 and it must communicate through Bluetooth. Then finally, we have our UX design. The game must have a start menu with a settings tab to sync the board connection and ensure this works. Make the connection logic and implementation as painless for the user as possible, and then ask any follow-up questions. We now have both of our models running in their respective terminals using Opus 4.6 in Claude Code, as well as GPT-5.3 Codex XI. Both of these are just being used through my subscription plan. So this one is the Claude Max 5X plan, the $100 a month one, and then Codex is the Pro subscription, which is the $200 a month one. So whatever we see used here today is just part of those specific subscriptions. I've not done anything additionally to that in terms of payment, though they are both still relatively expensive. And I did add one thing to the prompt where I specified it should be a 3D C++ game, as we don't want any photorealistic 2D junk. So with that, both of these are in their respective planning modes, so I'm going to initialize them by just telling them to read the requirements in the prompt.md, which we previously went through, and begin the task. If they have follow-up questions, they can ask me. If not, they will just create their plans of how they begin to implement this specific software or product. We get our first question right here from Codex. It has 3 unanswered questions for us. Okay. Fastest path to a polished 3D prototype with a simple build deploy. Okay, I'm cool with that. Next question. What delivery level do you want for the first milestone? 1 skate park map, 1 rider rig, animation set, all controls working end to end. I suppose I will just have it give me something simpler to begin, because then we can iterate upon that if it works well. And then finally, how should we handle 3D assets? I'm going to try custom created assets because that'll be more difficult. Let's attend to Claude now, which is just asking for some permission. Okay, so it wants to search the web, which I'm going to allow it to do because it asked me. And then we have some more follow-up questions right here. Which telemetry transport format should firmware send over Bluetooth? Okay, whatever it wants to do. How should we handle calibration thresholds for turn and ollie detection? This will be something important. In-game calibration wizard, absolutely, and that's why I specifically wanted that settings menu listed in the game like requirements for board sync and settings. What UX should we implement first? Yes, absolutely. That will make it most pain-free for the user. Cool. So far, I'm very happy with the follow-up questions that Codex has asked me. One more decision round is needed to make the gameplay acceptance criteria. What movements physics should the first build target? Yes, arcade, third-person camera. If telemetry drops during gameplay, what should happen? Yeah, that's fine. Okay, those were some thoughtful follow-up questions, I will say. So Opus 4.6 is still figuring out its implementation plan. It has not asked me any follow-up questions. Oh, okay. It's looking now. It's doing a lot of web searching, which is interesting. But I'm truthfully just going to allow this to function as it wants to, so feel free to do as you please. In the meantime, Codex has given us its plan here for us to look through and allow it to implement. Truthfully, because there's a lot here, I'm going to allow it to just basically go ahead. I will quickly browse through this just to see if there's anything egregious, but I don't believe there is. And here we have some of our board sync that it's mentioning. So essentially we can figure out how to initiate the ollie by capturing that neutral stance capture and then the tail press ollie gesture capture for the threshold, which I may have previously talked about very quickly. Okay. Custom riders, things of that sort, control and signal processing. I'll just let it try whatever it wants to there and we'll see if it works or not. And there's a pretty robust planning step right here, so I'm happy with everything I see. I'm going to allow it to implement the plan. Next up, Claude is just looking to see if it can fetch some specific gist commands from GitHub. So Claude seems to be going heavily into web-based research right here to figure out what exactly it is going to do with this, which is interesting. And I'll say Claude is running a bit slower, and I think that was pretty widely reported, is that Opus 4.6 was fairly kind of token heavy and a bit slower than I think what a lot of folks had experienced with Opus 4.5. We have our game architecture right here, custom lightweight arcade physics. So this has automatically decided upon a lot of the follow-up questions that we did receive from Codex, which is fine with me. Again, I'm not necessarily the results will speak for themselves. So this is really just difference in experience of how these are functioning. Okay, I spotted one behavioral edge case. If the board sends ready before the first telemetry sample, gameplay could immediately treat telemetry as stale. I'm patching board link to mark receipt time on ready as well. Okay, and this is prior to even like us being able to run it or anything. And whichever one of these does finish first, at this point I would imagine it will be Codex, just because it spent a lot less time in the initial planning stage. I'm going to wait till both of these are finished. Good, okay, we have our natural next steps, and then I'll test them one by one, just because the actual Bluetooth setup and everything will be probably still somewhat of a pain. So I'll have to make sure all of that is handled. Claude is saying, now the skater, the most complex part, because we did mention it needs to have like a little person with some movement, which both of these did display the ability to do in my individual testing videos of them. So I know they're capable of doing it. And we can see Claude is pretty quickly checking off its to-do list now, because it seems to have just tackled all of that. And then the culmination of that will be checking everything off and then giving us some additional information in a README, as well as testing to see if it actually works, which we will now allow it to do. All right, and it seems like everything here is all set. Shows us what is working, how to run it, and all of this should also be contained within a README markdown file, which will make this a little easier to actually parse and run the game. So our next step is actually going to be to connect this board physically via USB to this computer, just to upload the specific sketch for either game to the Arduino, and then the next step will be to, I suppose, try the result that finished first, which would be the Codex 5.3 result. So I'm not fully able to get the Arduino playing nicely with this specific system, and in lieu of just wasting time kind of troubleshooting that connection issue, which is not really relevant to this specific test, I'm actually just going to try a more compatible board, not like a really cheap replica like the one I'm using. So, all right, I've swapped the more compatible Arduino onto the board, which should take care of any issues with this computer speaking to it, all because of this little guy right here, this little chip, which can be a little more difficult to work with, but the plus side of that is these were like $3 each, although I did buy them many years ago, so I digress. All right, let's try now. We should see HC05. There we go. Good. Then we need to pair with HC05, or through its MAC address, which is listed right there. So pair 1, 2, 3, 4, I think is the default. Good. Then trust, MAC address, good, and then connect. MAC address. Now, I'm having difficulty actually building this game successfully. I have installed the dependency that it wanted me to have, so I'm telling it to just basically fix everything for me, keeping in mind that the Arduino is all set and the Bluetooth connection is all set as well. So it should be able to run this and then see, okay, good. And this is definitely one of the pros to having like agentic coding like this, is instead of having to deal with all this, you can just tell it like fix, and then it will go and more or less fix it. All right, so here's Skate GPT. So this is our first look at the Bluetooth Skate GPT. We need to pair our board in settings. Now this is going to, success in this is not directly related to whether or not the model did something right. There are always potential Bluetooth issues here, so please keep that in mind. Okay, we were on RFCOM 0, which is the one that we did have it connected to, so controls R, scan, C, connect, D, disconnect, W, calibrate, and kick-ass. That was kick-ass. It works. Do you see that? Connected. Okay. Now we're going to need to calibrate this, I do believe. So that would be W, stand neutral. Good. Okay, we did something and we see the, I'm actually, to be honest with you, I'm quite impressed right now. More so, I'm already further along than I thought I was going to be. So we can escape right now. Let's just play. Yep, it is working. And I didn't calibrate it properly, but keep in mind, this is like, and then that's awesome. And then the left mouse button was supposed to be to move. Come on, you can do it. Jump, you idiot. Yep. And I calibrated it wrong, or it calibrated it wrong or something. But the fact that this, I'm actually kind of impressed that this worked on first glance. And once I pop a battery into this, it will be wireless. So my intention with this is actually I will place this on the floor, run this game on a big monitor so we can actually see a look at the skateboard controlling the game, as well as the actual like game playing as well simultaneously. This was surprisingly well done on first try. No issues really whatsoever. Okay, I have feedback here just mainly because like the game looks kind of crappy. The animations could be better. The logic worked, so I'm going to quit it now and we're going to hop in and test our first try with the Claude result, which I'm excited. Now let's take a look at our Claude README, keeping in mind we will have to update our own script to the Arduino here as well to overwrite the one for the GPT working result. All right, truthfully, this is really kind of a pain in the butt, the specific library that Claude has opted to use for this, and because GPT had no specific issues in having to download a not proprietary, but a custom library here. All right, I'm just going to instruct Claude to fix this. Yep, that's the wrong folder. Unless close and reopen the Arduino IDE or just recompile, should find the headers now. Okay, we'll try that then. So here's our Claude skateboard controller folder again. The board is plugged in, nothing's changed, so perfect, it did work. Okay, then I was just trying to put the library folders in the wrong spot. So this is user error, but it does highlight that this had the ability to fix it. Now there was something else there in the README that I do believe I neglected to take a peek at, which was actually reconfiguring the Bluetooth receiver to work in a different manner. Hold the button on the HC05. I don't know that mine has a button. I'm telling it there's no button on my Bluetooth receiver, and on second thought, let's just make it a little simpler so we don't need to perform any configuration changes to the Bluetooth receiver, even if it's a little more jittery in gameplay, being that this is just kind of a tech demo. Okay, so now hypothetically, we should be able to re-upload this sketch for the Claude result to our Arduino, which we're doing right now, and it should finish in a second. Then we can go back to the README now and follow the remaining steps, although I do believe it gave us the remaining steps here as well in the terminal. All right, so here is our Claude skateboard game. We didn't need to go through all of the build steps because it had already built it, unlike the GPT one, which needed a dependency that I had to manually install. This one already autonomously did everything. So just in the previous section like we did, I'm going to go into settings. We now have our Bluetooth connection working. Is the telemetry reading properly? It is. Although it's kind of a bit laggy, so interesting. Although there's no specific, like, what's the word I'm trying to look for? We're not having to synchronize it at all like we did with the GPT result, which is pretty interesting. So show pairing help. And since we already did that for the previous result, that's why this one's just automatically working. Okay, this seems to be working much better now. And that's actually, the telemetry on this was more painless, I think, than the GPT one, although we have to see if it properly does reflect to gameplay. So, okay, here we have our gameplay. Let's see. Okay, so that ollied, and that was a side-to-side lane. So let me hold this up and then, okay, so, okay, stop ollieing. Can we, all right, let me just put this flat on the ground. Okay, it just keeps ollieing. Stop ollieing. Let me put it upside down again. Okay, so oddly, when it's upside down, it stops ollieing. Okay, so there's an issue with the synchronization logic of the telemetry reading this is getting from the gyroscope, because as we can see, it does reflect to it like we saw when we went into the settings menu. We were actually able to see the reflection of the Bluetooth device and the accelerometer. The problem is with the skateboard, even so, if I put it upside down like this, it stays within the circle a little better. But even when I had it upside down, this was not reflecting the actual lean at all in the game. So that will be an improvement we need. I'm now starting on the game improvement round, and I've just put them back into plan mode, but I've pasted in the prompt for the improvement that I want, essentially telling each what is specifically wrong with the issues I noticed. I went back into the GPT game just to check things, and I noticed it was working worse than what we had previously seen when we actually ran it for the first time, which is somewhat perplexing, but I do believe that the orientation of the accelerometer is something that would be extremely helpful for these to understand how specifically they should properly be getting those metrics. So I've gone and included 2 reference photos in either of their respective repositories. So we have reference 1, which is just a real close-up of the way the accelerometer is mounted with respect to position and on the underside of the board and things of the sort. Following that, I've just basically given them a zoomed out photo so they can understand and kind of map in space where the actual accelerometer is placed on this board, so they know the underside of it. In addition to that, I told both of them I just want the game, like graphics and everything, to look much better. I'd like some actual movement of the body of the rider, because both of these have actually implemented that successfully in previous testing. Additionally to that, I told the Claude result, or I told Claude that about its result, it should probably have some way to actually measure the movement of the board in threshold, just the way that the GPT result did, so we could actually get a baseline to properly have some movement. All right, they're both done, and I'm going to now try the Claude result first, just because I may have messed something up when attempting the GPT result, which I now realize would make me look foolish if I showed that clip. So with that, we're going to go into our Claude folder, and we're going to once again upload the Arduino script for our Arduino. All right, then the next step, because it did build the game while it was testing, so we should be basically ready to just go ahead and start it. And keeping in mind the skateboard is in the orientation in which it would be when actually playing this game. So let's go into our settings, and we are now connected to our, okay, it did add in the calibration, but before we do that, I want to just check the tilting. And it's odd because the connection on this one is significantly worse in terms of the lag time for the Bluetooth to actually receive or send the signal to the computer. It was something that there, now it updates in real time. Tilt looks good. We do have some semblance of like a lean delta for the ollie, so let's try our calibration. Calibrate, board flat. Oh, okay. I'm now gonna... Skateboard looks way better. Let's try a lean. Okay, it ollied. Let's just try another. If I hit the tail here, we should ollie. I think the axis is inverted. Look at the foot movement. That's really good, actually. The biggest problem here is the lean. So this works much better, I'm going to say. First and foremost, I'm going to use the keyboard now to save us. That is impressive though. Look at the way it actually shows like pumping on the ground of the foot, and the arms reflect that. I'm impressed with that. And if we do pop the board, once we get away from this pole, we do get an ollie, at least when we were getting one. Significantly better. Let me try the GPT result before we make a determination. So we're back into our GPT result. I think I would say the actual aesthetics of the game menu look better with the GPT result, which is surprising because Claude is known more for its aesthetic capability. Okay, we have our controls: scan, connect, disconnect, mount, which has the mount preset that can be changed. So that's top side preset, custom preset, underside. Well, the mount is on the underside, so I'm going to set it to that. Then calibration is W, so hold it neutral, okay? Play. Okay, the actual people look rather similar. Sadly, it's working much worse now than it had previously. Let me try changing the mount preset. I'm very much starting to regret opting for this. I should have just done like a racing game with that arcade cabinet that I built. I'm asking Codex a follow-up, just basically saying why isn't the movement being controlled at all by the board. I'm saying it's also the board is moving sideways, which is more of a gameplay issue, but I figure if it's going to answer that, it can fix that in its answer as well. For Claude, it definitely worked significantly better. I really think the only thing was the side to side did not fully reflect the movement, but I'm just going to ask. I don't necessarily even want it to make any changes. Now I'm just asking the Claude result, saying I don't see it like fully responding to the side to side. It seems like the up and down or the pitch, the roll, whatever, is also affecting direction. So I'm asking it if this is how the specific code is telling it to function. So Codex has given us some update, which truthfully I was over getting a script that would probably give them the correct answers here. So I didn't necessarily see specifically what it said, but it did just say it changed something and you can now run the game and try it again, which is exactly what we're going to do right now. It started out promising, but it's just bad now. I'm just trying to help the Claude result now, at least because it's a little more promising so far in this specific iteration, where basically I'm telling it the control in turn needs to be controlled by pitch. I'm saying put a dead zone in pitch from maybe -4 to 4 so that we don't get any movement there. And then from that 4 to 20, as we see in this pitch value right here. So here I'm turning the board to the left, and we can see the pitch value sitting right around like 20 at maximum lean, which we'll probably experience in playing this game. And then pitch goes back to 0. And then when I turn it right, pitch will go negative and then to about -20. So I'm just telling it to make that pitch value reflect the actual turning of the board instead of what it's using right here. So I'm going to close this app right now and then have it make that change, and then including that dead zone so that it's not hypersensitive, so that like some general back and forth movement doesn't make it freak out. Let's try this again now. We can just immediately go to gameplay here. So hypothetically, left and right when we're moving forward. Here's left. And then, okay, so it's inverted, but it's also, this is due to lag from our Bluetooth. So if we hold it here for like a few seconds and then we start moving again, we'll see that it's actually properly relaying the correct orientation. It's just unfortunately a little slow, but this is actually now working. I don't know. Perfect. This is playable. All right. And as I said that, the GPT Codex result has now concluded. So let's see what it's done here. I'm just going to play it and we'll see how it does. I've also, just in preparation, if this does fail, I've given it a sketch from many years ago that I know properly will at least show how the value should be being pulled from this accelerometer. So I can give it that if needed. First and foremost, we need to upload our Arduino firmware sketch. I think I glitched out there for a second. I was staring at it like, and it had already uploaded. Now we'll try our game one more time. Settings. Okay, so we need to calibrate. Okay, so we've run our calibration wizard. I'm definitely seeing a change. Oh, okay, so it's... That looks way better, though. I'm going to give this the same exact prompt that I gave Claude to try to fix it. And then I would assume we'll have working results for both of these once it produces this, which is actually kind of cool. All right, now let's see. Good. Well, better, I should say. Yep, much better, kind of. And I did just see an ollie for a bit. Okay, the only issue here now is it's inverted, that's it. And it did even mention if that is an issue, it can just add the invert turn toggle. I was going to say to it, I feel like the entire configuration we need to go through is kind of cumbersome, but I don't even want to risk messing stuff up because we're pretty much ready to actually try these for real, which is awesome. Yep, I saw one. It's pretty like aggressive, but... All right, so the final thing I want to mention here before we actually start to test these games in real life is the specific information about the usage here. So we can see for Codex that in our context window in this chat, we used 184 of the 258,000 tokens. Our 5-hour limit, there's a ton left, as well as our weekly limit. So that seems to be pretty well done. And keep in mind, I did use the Codex application as well in the testing of the video for this. Then in Claude Code, we have here our current session is 20% used up, reset 7 p.m. And keep in mind that the Claude Code subscription I'm using is the $100 Pro Max. It's the 5X Max plan for $100 a month. And GPT plan that I'm using is $200 a month for the Pro subscription. All right, we have 2 working results here now, and it's time to play them. All right, can we ollie? Can we ollie? There we go. Come on, come on. Can we ollie? Come on. Yeah, we did an ollie. Nice, nice. All right. So that's really going to conclude this video. As I may have said in the beginning, I wanted to test these in a more creative way than just like a simple game that just runs only on the computer, which I like doing, but not for a dedicated agentic head-to-head. This was a lot of fun, and I think overall, were I to pick a better result, I would probably have to go for Opus 4.6 because the ollie logic actually worked and the actual aesthetics of the game seemed a bit better, which is obviously a pretty subjective statement, though I will say the actual menu screens, Codex 5.3 definitely blew Opus away in terms of the aesthetic of the menu screen, which was pretty interesting. Now, I can't actually play the Codex result right here because it does not have a Bluetooth connection to the skateboard currently. It's not plugged in, so it won't let you play it without that. We can quickly hop into the Claude Skate one, which did also implement the kind of backup controls here for the functionality of this, just in case you wanted to test it. So overall, I guess it's harder to judge them based on aesthetics, I suppose, but the actual functionality was better with the Claude game, and that was interesting, being that the initial result, the Codex result, blew Claude away on the first test, but then when we iteratively improved them, the Claude one definitely pulled ahead. So really, that's going to conclude today's video. If you have any questions, please feel free to leave them in the comments, and thanks for watching.